Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing basics and algebra of sequences. The nth term of a sequence is 8n minus 3. Write down the first two terms of the sequence. So you should know that n is the index of the term. So it's like the fifth term or the sixth term. This means n equals 5 or n equals 6. So the first two terms translates into n equals 1 and n equals 2. This would be the first term, and this would be the second term. So for term 1, and we call this u1 or a1 or whatever, this will be 8 times 1 minus 3, and this is equal to 5. And then u2 would be 8 times 2 minus 3, and this is equal to 13. So basically, we plug 1 and 2 in n to get the first term and the second term. Show that the number 203 is not in the sequence. So n can only be a counting number. So it can be 1, 2, 3, 4, and so on. It cannot be negative, it cannot be 0, and it cannot be a decimal. Because n is the index of the term. It's the first term or the second term. So you cannot have a 1.5 term, for example. That does not make sense. So if we get any value of n that is not a counting number, then this is not in the sequence. So let's try to solve for n. Let's say 203. This is a term in the sequence, and it has to follow the rule of the sequence, which is 8n minus 3. This is the value of the term, and we want to get the index of the term. So to get the index, which is n, we solve this equation for n. We take the 3 to the other side. So 203 plus 3 equals 8n. And then we simplify and divide by 8 in order to get the value of n. So 206, which is 203 plus 3, divided by 8 equals to n. And you can use your calculator to evaluate the value of n. So 206 divided by 8 gives us 25.75. And this tells us that this term does not belong to the sequence because n cannot be a decimal. It has to be a counting number. So n cannot be decimal. So 5 and 13 are correct. And in double I, we show that n is equal to 25.75, and this is not possible for the index of a sequence. You cannot have a term that is equal to, so the index of the term cannot be 25.75. It has to be either 25 or 26. Another sequence has nth term 2n squared plus 5n minus 15. Find the difference between the fourth term and the fifth term of the sequence. So we said that the fourth term is called u4, and the fifth term is called u5. And we want to get expressions for u4 and u5. So u4 is obtained by plugging 4 in n. This is kind of like functions where you do f of 4. This is kind of the same idea here. So it's 2 times 4 squared plus 5 times 4 minus 15. And you can use your calculator to evaluate this. So 2 times 4 squared is 32. So 32 plus 20 minus 15. And this gives us 37. And then for u5, we're going to do the exact same thing again, but we're going to plug 5 instead of 4 in n. So we get 2 times 5 squared plus 5 times 5 minus 15. And if we simplify this, we get 50 plus 25 minus 15. This is equal to 60. They want the difference between the terms, so we have to do 60 minus 37, and this is equal to 23 as a final answer. And 23 here is correct. The nth term of a sequence is 60 minus 8n. Find the largest number in the sequence. So the largest number here is obtained by figuring out what the constraints of n are. So we said that n must be greater than 0 because n cannot be negative and it cannot be 0. The first term is 1. So the smallest value of n is 1. You can actually rewrite this as n is greater than or equal to 1, remembering that n can actually not be a decimal. So it cannot be a decimal. It can be either 1 or 2 or 3 and so on and so forth. So if we put n as 1, we get 60 minus 8 times 1, and this is equal to 52. If you put n as 2, for example, you get 60 minus 16. 8 times 2 is 16. So this is 44. So you can see that the number here, the value is decreasing. So this is going to be the largest number here. And any value after that will keep decreasing. So therefore, the largest value here is going to be 52. This is going to be our final answer. 52 is correct for A. The nth term of another sequence D is negative half to the power of n minus 1. Complete the table for the first 4 terms of the sequence D. So the first term is U1, and it is obtained by putting 1 instead of n in the equation. So let's rewrite the equation here. It's negative half to the power of 1 minus 1. Here it's going to be negative half to the power of 2 minus 1. This is going to be negative half to the power of 3 minus 1. And for the fourth term, it's going to be negative half to the power of 4 minus 1. So the idea is that you remove n and you put the index of the term, whether 1 or 2 or 3 or 4. Next, you just simplify and find the final answer of each. So for this one, it becomes negative half power 0, and this is equal to 1. Here we have negative half power 1, and this is equal to negative half. For the third one, we have negative half power 2. This is equal to, 1 over 4. For the fourth one, we have negative half power 3. And this is equal to negative 1 over 8. You can use your calculator to get these values. If you can't do them mentally, that's okay. So these are the values that we put into the table. We just put 1, negative half, positive quarter, and finally, negative 1 over 8. So these are the correct answers, 1 and negative half, and then 1 over 4, and then negative 1 over 8. They are put this way in the marking scheme for something that has to do with the allocation of marks. So this is worth 1 mark, this is worth 1 mark, and this is worth 1 mark, because the quarter and the negative 1 over 8 require more calculations than the first two. So anyway, we know now that these are the correct answers. The sum of the first n terms of a sequence is n times 3n plus 1 over 2. When the sum of the first n terms is 155, show that the following quadratic equation applies. So we want to equate the sum to 155, and we want to solve for n. So we have n times 3n plus 1 over 2 equals 155. So the first thing we can do is we can take the 2 to the other side and multiply. So 155 times 2. 155 times 2 is 310. And this is equal to n times 3n plus 1. Then we can distribute the n over the bracket. We get 3n squared plus n equals 310. Finally, we can take the 310 to the other side, and we get 3n squared plus n minus 310 equals 0. And this means we have reached the correct final answer because our equation is exactly the same as the one we were trying to reach in I. So we have the correct answer here. In double I, we are told solve 3n squared plus n minus 310. So you can either use the quadratic formula or factorization, but of course, the quadratic formula makes more sense, or you can even do mod 5-3 if you're allowed a calculator. So you can just do mod and then select the equation, and then you just put 3 for the A and 1 for the B and negative 310 for the C, and your calculator gets you the values. So we have negative 31 over 3 and 10. So n equals negative 31 over 3, or n equals to 10. And this tells us that if we were to factorize, we would probably get 3n plus 31 and n minus 10 as factors. But anyway, you don't have to factorize here, but I'm just telling you that you can use the solutions of the calculator to figure out what the factors are. So the answers here are negative 31 over 3 and 10. In double I, we were just asked to solve the equation in terms of algebra, but we're not really asked to figure out what this means in the context of the sequence itself. However, in triple I, we need to figure out in context of the sequence, what does this mean? So is n negative 31 over 3 or positive 10? Of course, n is positive 10 because you cannot have a negative value or a decimal for n. So it has to be the positive whole number. So the answer is the sum of the first 10 terms is 155. So these are the correct answers here. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.